Okay guys, welcome back. So in the last video I talked about some special angles and some how when the angles are increased or decreased, what happens to the value of the resultant force of the total net force, and how the total net force and on which range the total net force acts. So what's the minimum value a total net force, if any two forces you are given, what's the minimum value it can get, what's the maximum value it can get. So if you are not watched that video, I invite you to watch that video and come here. So that will be very important to you. So in this video I will be talking more about the force decomposition. Alright, so what if you were given a system like this? So this is the question I am asking you. What is the resultant of this force distribution? Alright, so there is a force 5 newtons in this direction, which is horizontal, and there is a force of 8 newtons in this direction, which is 60 degrees. This is measured counterclockwise, so anti-clockwise. 8 newtons, which is 60 degrees inclined to the horizontal. There's a 2 Newton force which is vertical. Another 4 root 3 Newton force which is measured clockwise and is 30 degrees inclined to the horizontal. So what is the resultant of this force system? So this is a very simple sum. So what you need to do is that you have to decompose it into this horizontal and the vertical directions. Alright, so I'll take the positive x-axis as this side and the positive y-axis as this side, right? So the positive horizontal components will be in this side, and the positive vertical components will be in this side. So I will take the components in this side as f r x, and the components to this side on the vertical direction as f r y, right? F r x and f r y. So I need to find f r x, I need to find f r y first. So to find f r x, I will say f r x equals, so I have already taken the positive horizontal directions in this direction, positive horizontal forces in this direction. So what I need to do is that I have to decompose these forces. So I already have a force of 5 Newton in this direction, so I am taking the positive direction as this direction, so 5 will be positive. So f r x is equal to 5. So this is 8. Now I need to decompose this force into its horizontal and vector composition. So if you decompose this force into its horizontal composition, I will first calculate the horizontal compositions and then calculate the vertical compositions. So the direction will be in this direction, so that is positive, and this angle is 60, this is 8, means the horizontal composition will be 8 cos 60. So 8 cos 60 is positive, so cos 60 is equal to half, so 8 cos 60 is 8 times half, 4, and that will be positive, so plus 4 here. And 2 newtons is vertical, and you can take it into the horizontal composition, but you can take the 4 root 3 newton because it's angled. So this angle has been given as 30 degrees measured clockwise. So if you decompose this one, you have to decompose the horizontal composition will be in this side, so that will be in the negative direction. So you have already taken the positive direction as this direction, so this will be in the negative direction, so it will be minus 4 root 3 cos 30. So 4 root 3 cos 30 will be 4 root 3 times cos 30 is root 3 by 2, so that will be 2 times 3 6. So that will be, you have to subtract that from this one, 6. So f r x will be equal to 4 plus 5 is 9, 9 minus 6 is 3 newtons. Alright, f r x is equal to 3 newtons. So f r y is equal to, f r y is equal to, so this force you can take because this is horizontal, but you can take the horizontal vertical composition of this force. So this force is 8. I have taken a positive direction as the upper direction. So this force, when you decompose, it will be in the upper direction. So it's positive. So the force in that direction is 8 sine 60. So sine 60 is equal to root 3 by 2. So 8 sine 60 is 8 times root 3 by 2, which is 4 root 3, and it's positive. So it's 4 root 3. And this force 2 Newton is already in this direction. I have taken the positive direction as this direction, so it will be positive. So plus 2. And this force 4 root 3 when you decompose it into its vertical component, it will be in this direction. So I have already taken this direction as positive, so this will be also positive. So the force in this direction will be 4 root 3 sine 30. So 4 root 3 sine 30 is half, so 4 root 3 sine 30 is 2 root 3. So that's also positive, you have to add that. So the total force in the total force in the y direction will be 4 root 3 plus 2 root 3, 6 root 3 plus 2. 6 root 3 plus 2 newtons. Right? So we have to find the resultant force. So we know that the positive x direction I have taken this direction, so Fr x positive is in this direction, Fr y positive is in this direction. Right? So this force is equal to Frx is 3 newtons, and this force is equal to 6 root 3 plus 2 newtons. Right? 6 root 3 plus 2 newtons. So we need to find what is Fr. So as in the last problem, we can put the Pythagoras theorem to find Fr. So from Pythagoras theorem I can write Fr is equal to 3 square plus 6 root 3 plus 2 whole square. So this is 3 square is 9. Right? 3 square is 9. 6 root 3 square is equal to root 3 square is 3, 6 square is 36, 36 times 3 is 108 plus 2 times 6 root 3 times 2, so 2 times 2 is 4, 4 times 6 is 24, 24 times root 3 is 24 root 3 plus 2 square is equal to 4. So 108 plus 9 is 117, 117 plus 4 is 121 plus this 24 root 3 will be as same. So 24 root 3, you can say 24 times root 3 1.7. So it is 28, 14, 6, 24, 8, 10, 4. Alright, so this will be approximately 40.8. I'll take it as 41. 21 plus 41. So the resultant was Fror is equal to approximately 162 newtons. Right? R is equal to 162 newtons. So what it actually means is that this angle, I will take this angle is alpha. So I will calculate that as well. So tan alpha is equal to 6 root 3 plus 2 divided by 3. So alpha will be equal to tan inverse, right? Alpha will be equal to tan inverse 6 root 3 plus 2 divided by 3. So 6 root 3 will be 1.7 times 6, which is 10.2 approximately. So this will be 12.2. This will be approximately 4.1. So alpha will be approximately tan inverse 4.1. So I will not find the value of tan inverse 4.1. So that's the angle. So what it means is that if I take an object here, right? If I take an object here, if I keep an object like this, what it means, if I put all the forces on this object, this force, which is 162 newtons, can replace all the other forces. So alpha will be this direction. So this is alpha. So alpha is equal to tan inverse 4.1. We just found it, and this force will be 162 newtons. Right? So what it means is, if I put all these forces on this object, right? All these forces on this object, this 162 Newton force, which acts at an angle of tan inverse 4.1 in the counterclockwise direction to the horizontal, will replace all these forces and will have the same effect as the other forces. So the total acceleration of the object will be of the total acceleration due to these individual forces in these directions will also be the total equal to the total acceleration due to this force measured tan inverse 4.1 degrees counterclockwise in this direction. So that is about the decomposition of forces. So in the next video I will present you with a more complex topic on more complex problem. So this is only 3 or 4 forces. So in the next video I will present you with the more complex problem on decomposition of forces. So see you then.